Okay, hydrolysis. The reaction of anion or cation of salt with water, accompanied by the cleavage of Weiss hydroxide bond of water molecule, is called hydrolysis. For example, it's the general example of anion is reacts with water and produces hydroxide ion, and this cation uh, produces hydrox H plus ion, hydronium ion. It is the reaction of cation and anion of the salt with the water is called hydrolysis. Hydrolysis is the just opposite process of neutralization to the process of neutralization hydrogen, and hydroxide combine to form undissociated water molecule. But in the process of hydrolysis, there is a formation of hydronium ion plus hydroxide ion by the dissociation of water molecule. Depending on the hydrolysis behavior of water molecule, depending on the hydrolysis behavior, salt are classified into following: quantity or mathematical treatment of hydrolysis of salt. Hydrolysis of salt occurs when its ions react with water to produce an acidic or basic solution. The extent of hydrolysis is measured using hydrolysis constant Ks and degree of hydrolysis S. Salt hydrolysis depends on strength of parent acid and base. Salt of weak acid and weak strong base, for example, sodium ethanoate, sodium cyanide, sodium methanoate are the example of this type of salt. Potassium cyanide is the salt of weak acid and strong base, and it ionizes to form potassium plus and cyanide ion, strong conjugate base of weak acid, cyanide ion, which is relatively strong base, and cyanide reacts with water, produces hydroxide ion. Solution becomes basic nature due to liberation of hydroxide ion. For example, sodium ethanoate and hydrolysis of iron reacts with water and hydroxide produced. So hydrolysis constant K is Kw over K. Hydrolysis constant K is Kwk. Degree of hydrolysis and pH of the solution. Sodium ethanoate hydrolyzes with water and produces the ethanoic acid in strong base, weak acid and strong base, sodium hydroxide. And neglecting the common ion effect on both sides. Calculation of hydrolysis constant, let us consider the example of hydrolysis of sodium ethanoate produces weak acid, ethanoic acid and sodium hydroxide. Anionic analysis, weak acid, 3 base, neglecting the common ion effect on both sides. In general, if Ba is the salt of then anionic hydrolysis is represented by A minus S2 plus Ha plus OH minus. Now applying the law of chemical equilibrium, the equilibrium constant is represented by Kc. And so we can add KCS2O. Since water is present in the large excess, KCS2 is the constant, and we put Kh into KCS2, which is hydrolysis constant. K is equal to Ha, OH minus, A minus. When the equilibrium reaction is established, as in the equation first, the ionization of water and weak acid also should be considered. Ionization of water takes place S plus OH minus ionic product water S plus OH minus is a minus S plus. The ionization constant of case it is given by K equal to S plus A minus SA. Question 4. Dividing equation 3 by equation 4, we can write the equation 2 K is equal to HAOH minus H minus. So KW over K equal to KH. Calculation of degree of hydrolysis. If C mole per liter be the initial concentration of salt and alpha be the degree of hydrolysis, then the concentration pertinent chemical species at equilibrium are given by A minus A9 plus water reacts as Ha plus OH minus. Initially, C concentration water is excess and zero concentration of Ha and hydroxide ion. At equilibrium, C minus 0 alpha equals C alpha, C alpha. K is equal to HAOH minus A minus. So K is equal to C alpha square 1 minus alpha. If the value of alpha is very small as compared to 1, then 1 minus alpha tends to 1. So K is equal to C alpha squared. So alpha equal to root under K is over C. From equation 5, Kw equal to K equal K. So alpha equal to root under K W C. So alpha equal to root under KWC KCK equation 7. Calculation of pH of the salt solution if the C mole per liter be the initial concentration salt and alpha be the degree of hydrolysis, then concentration of pertinent chemical species at equilibrium are given by A minus reacts with Na and reacts with water, Ha plus OH minus. Concentration C after A minus and water is excess. At equilibrium, C minus alpha and SaNOH C alpha C alpha. We have hydroxide C alpha, so KWOH plus OH minus is plus KWOH, so H plus equal to KWC alpha. Now applying the value of alpha from the equation 7, alpha equal to root under KW over CK. So H plus equal to KW over C root under KWCK. H plus equal to root under KWK over C. Taking minus log on both sides, minus log H plus equal to half log KWK over C. So solving, we get pH equal to half pKW plus pKa plus log C, equation 8. At 25 degrees Celsius, pKw 14, so pH equal to 7 plus half pKa plus half log C. It is concluded that the pH of salt solution of this type is always greater than 7. That is, the solution is basic for particular types of salt. So salt of the values of pK is constant and pH of the salt solution is the function of concentration of salt. So pH of the salt solution increases with increasing concentration of salt. Salt of weak base in strong acid, ammonium chloride, ferric chloride, copper sulfate, etc. The example of this type of these salts which undergo cationic hydrolysis and resulting solution becomes acidic nature. Uh, Hydrolysis constant K is equal to Kw over Kb and degree of hydrolysis is equal to root over Ks over C, K is equal to Kw over Kb. So we can write K is equal to root over Kw Kb over C. Some examples of salt formed by strong acid and base are the copper sulfate, copper nitrate C. Let us take an example of copper sulfate dissolved in water and dissociate into copper plus 2 and sulfate ions. The ions interact with water as plus copper sulfate plus water, copper hydroxide plus sulfuric acid. So copper sulfate plus copper plus 2 plus sulfate, water, copper sulfate, and water sulfuric acid. Hydrolysis constant case in general, if B is the salt of then cationic hydrolysis is represented as B plus S2O BOH is plus the free acid. Now applying the law of chemical equilibrium, then equilibrium constant can be expressed Kc equal to BOH S plus over B plus S2O. So KCS2 equal to BOH S plus B plus. So KH equal to BOH S plus B plus equation second. Kh is the hydrolysis constant of salt when equilibrium of hydrolysis reaction is established and also ionization of water and weak base BOS occurs. When water ionizes S plus OS minus equation third, the ionic product of water Kw equal to H plus OS minus. The weak base ionizes also ionizes BOS B plus OS minus. The ionization constant of weak base Kb equal to OS minus B plus BOS equation Bi. Now equation IB is divided by equation BI and we get Kw over Kb, we get S plus B will be minus. So K is equal to BOH S plus B plus. Kw over Kb equal to Kh. So Kh equal to Kw Kb. Equation 7. From the equation 7, it is found that the particular temperature, the value of Kw is fixed and Kh proportional inversely proportional 1 over Kb. This shows that weak base will be the higher hydrolysis constant and vice versa. Calculation of degree of hydrolysis. The degree of hydrolysis of salt is defined as the number of molecules of salt undergoing hydrolysis out of total number of molecules of salt. Degree of hydrolysis is the fraction of number of salt undergoing the hydrolysis. So mathematically, degree of hydrolysis alpha equal to number of molecules of salt hydrolyzed over number of molecules of salt present. Number of mole of salt hydrolyzed over number of mole of salt present. If C mole per liter be the initial concentration of salt and alpha be the degree of hydrolysis at equilibrium, then the concentration of pertinent chemical species at equilibrium are given below. B plus S2, BOS is plus is the initially concentration C, axis of water and initially 0. But at equilibrium, the BOS in S plus forms C alpha. So concentration of B plus C minus C alpha. Hydrolysis constant K is equal to BOS and S plus B plus. So substituting the concentration, we get C alpha square 1 minus alpha. K is equal to C alpha square minus alpha. Alpha is very small as compared to 1. So 1 minus alpha tends to 1. So K is equal to C alpha squared. So alpha equal to root over K is over C. Also we know that K is over Kw over Kb. So alpha equal to Kw over Kb over C. And solving, we get Kw over Kv as C and alpha equal to Kw Kv over C, root under Kw Kv C. Calculation of pH of the salt solution from the equation B plus S2 and BOSS plus. And we have S plus C alpha equal to C root over Kw over Kv and solving we get S plus equal to root over CKw over Kv. Taking log on the both sides we get minus log S plus equal to minus log CKw over Kb and minus log S plus means pH. So in solving we get minus half CKw over Kb and solving minus half log Kw minus log Kb plus log C half minus log Kw minus log Kb minus log Kc minus log Kw is the pKw minus log Kb pKb, so minus pKb minus log C at 25 degrees Celsius pKw 14. Now above equation becomes pH equal to half 14 minus pKb minus log C. So we get pH equal to 7 minus half pKb minus half log C. Salt of strong base in strong acid, example sodium chloride, potassium chloride, sodium bicarbonate, potassium sulfate, etc. are the example of this type of salt. This salt, when dissolved in water, producing the strong acid and strong base, so that strength of hydrogen H plus and OH minus hydroxide ions remains unchanged, and the solution will be the neutral and does not undergo further hydrolysis. It is the example of sodium chloride. Let's take the hydrolysis, Na plus, anyways, HCl, and Na plus HCl minus S2. Water also dissociated, neglecting the concentration of ions on both sides. When sodium chloride is dissolved in water, then only ionization of water takes place, and there is no interaction of cation or anion with water. Hence, salt formed by a strong acid and a strong base do not undergo hydrolysis. Since the molar concentration of H plus and OH minus ions are equal, the resulting solution is neutral. It's also expressed NaCl and NaCl minus Na plus S2, NaOH plus well, and similarly chloride plus S2, HCl plus S2. And sodium hydroxide and hydrochloric acid being strong electrolytes undergo dissociation, hence there is no interaction of sodium plus and chloride ions. So sodium chloride does not hydrolyze. Similarly, salt of strong acid and strong base do not undergo hydrolysis. Salt of weak acid and base, sodium ethanoate, ammonium chloride, ammonium ethanoate are example of this type of salt. Both cation and anion produced by the ionization of salt undergo hydrolysis, and resulting solution becomes acidic or basic or neutral depending upon the relative hydrolysis of cation or anion. Hydrolysis constant K is equal to Kw over K over Kb, and degree of hydrolysis root over K is Kw over Kb. Let us see an example of ammonium ethanoate. It dissolved in water. It undergoes complete dissociation to give it a ethanoate ion and ammonium ion. These ions interact with hydrogen ion and hydroxide ions of water to form weak acid and with base, so resulting solution is almost neutral. Ammonium ethanoate reacts to water and forms ethanoic acid and ammonium hydroxide. This ammonium ion and ethanoate ion reacts with water and produces ethanoic acid and ammonium hydroxide. Cationic and anionic hydrolysis acid with base, since cations as well as anions of the salt interact with water to give weak acid and weak base. That is the cationic and anionic hydrolysis. Calculation of hydrolysis cost in case. Let us take an example of hydrolysis of ammonium ethanoate, and ammonium ethanoate reacts with water, produces ethanoic acid plus ammonium hydroxide. And similarly, ethanoic ion and ammonium ion reacts with water to produce ethanoic acid and ammonium hydroxide. In general, if BH, the salt, is dissociated as flows, B plus A minus, the anionic as well as cationic hydrolysis reaction is represented as Ba equal to B plus A minus. And BO is SA. Now applying the law of chemical equilibrium, the equilibrium constant is written as Kc equal to BOS SA over B plus A minus S2. And solving we get Kc equal to KCS2 equal to BOS SA B plus A minus, and KCS2 equal to Ks. So K is equal to BOS SA B plus A minus. When equilibrium reaction is established as in the equilibrium force, the ionization of the water with acid and with base takes place. Ionization of water and ionic product of water, KWS plus OS minus, ionization of weak acid, H equal to H plus A minus. The ionization constant of weak acid, K equal to S plus A minus AC. The ionization with base, Kb equal to B plus OS minus BOS. Now equation third is divided by 4 and 5. We get Kw over Kb. And solving, we get K is equal to Kw K over Kb. Equation 6. Degree of hydrolysis alpha, if C mole per liter be the mole concentration of salt initially and alpha be the degree of hydrolysis, the concentration of pertinent chemical species are given. This cation in NiDX water and produces BOS and SA. And initially and equilibrium. Now applying the law of equilibrium, K is equal to HABOS A minus B plus. And solving alpha square 1 minus alpha square, if degree of hydrolysis is very low, then 1 minus alpha tends to 1, so that K is equal to alpha square. Alpha equal root over K is, that is root over KW K KB. So alpha equal to root over KW over K KB. Question 6. Calculation of pH of salt solution for weak acid. The ionization constant of weak acid K equal to H plus minus H. So H plus equal to K H plus A minus. Again, we know that B plus A minus S2, BOH is HA. So HA equal to C alpha, A minus equal to C minus C alpha. So H plus equal to K C alpha over C minus C alpha, and we get K alpha 1 minus alpha. If the value of alpha is very small as compared to 1 when alpha tends to 1, so is plus K alpha equal to Ka root over Kw Kb, and we get H plus equal to root over Kw over Kb. Taking log to the both sides, minus log is plus, minus log K root over Kw Kb, and solving we get pH equal to minus half log Kw plus log K minus log Kb. Again, solving half minus log Kw plus minus log K minus log Kb. So we get pH equal to half pKw pK minus pKb. Question 7. At 25 degrees Celsius, pKw equal to 14. So pH equal to 7 plus half pK minus pK half pKb. Question 8. Equation 7 and 8 shows that the pH of the salt solution does not depend upon the concentration of salt. The pH value of salt solution depends upon the pK and pKb value. So case first, if pK equal to pKb, then pH equal to 7 and solution is neutral. Case second, if pK is the greater than pKb, then pH is greater than 7 and salt solution is basic. Case third, if pK is less than pKb, then pH is less than 7 and solution is acidic. Okay, it's all about hydrolysis. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That is now bye bye. See you again.